So if we have a difference of squares, we're subtracting two perfect squares. We have a way to factor that. What if we're adding together two perfect squares? Can we factor that? Well, feeling our way in that direction, we might say, okay, what if we take our a squared minus b squared and we somehow reverse the sign of the second term? Let's replace just this b, which we can think of as something positive, by something negative. So a squared minus b squared is a squared minus negative c squared. But if I take negative c and square it, negative times a negative is positive. I'm going to be left with a squared minus c squared. I'm not sure I like that. What about in the factored form, right? If I take my a minus b times a plus b, so that'll be a minus negative c times a plus negative c. Well, a minus negative c, that's a plus c. A plus negative c, that's a minus c. What I've done here is just kind of switched the order. These are the same form. So that's not going to get me any way to find a factorization of a sum of squares. Let's try an example with kind of small numbers. All right, let's try to factor x squared plus 9 using the AC method. And of course, we need to stick in a 0x term. So we're looking for two numbers that multiply to positive 9 and add up to 0. Well, we could take 1 times 9. 1 plus 9 is 10. That's not 0. We could take positive 3 times positive 3. 3 plus 3 is 6. Still not 0. Negative 1 times negative 9. Those add up to negative 10. Negative 3 times negative 3. Those add up to negative 6. Okay. Well, we've got a good news, bad news situation, right? We can't factor this, but at least we know we can't factor this, right? We see the AC method fails, so we know that this is prime. Let's see. Was this special? The thing that went wrong here is that any two numbers whose product is positive 9 have to have the same sign. And there's no way I can add together two positive numbers and get 0. There's no way I can add together two negative numbers and get 0. If I want to add two numbers and get 0, they have to have opposite signs. There's no way that two numbers can have product positive 9 and have their sum be 0. And that's going to happen with every sum of squares. As long as we're limited to the real numbers, any polynomial of the form a squared plus b squared cannot be factored as a product of two binomials. It just won't work. So there's good news and bad news about the sum of squares. The bad news is we can't factor it. The good news is we know we can't factor it, which is almost as good as having the factors. At least we know we don't need to keep looking.